Okay, so this is actually the maths tutorial for the topic of Chem equilibrium, and we will be looking at discussion question 1 first. So this one, right, this first question is taken from a past year A-level 2017 paper 1. So in this question, you are told that the use of data booklet is relevant, and you are told that water ionizes according to this particular equation. So you have two water molecules giving you H3O plus and OH minus ion, and you are told that the equilibrium constant for this reaction is given as this. So this is actually consistent with what we have learned about how we write Kc expression. And then you are told that the density of pure water at 298 Kelvin is 0.997 gram per cm cube. And then you are told to actually determine from the following option which one gives you the number of H3O plus ion that's present in 1 dm³ of pure water at 298 Kelvin. So one look at this, right, the first thing that comes to my mind is if I need to know what is the number of H3O plus ion, so what I need is basically I need to know what is the number of moles of H3O plus ion in 1 dm³ of water, because once I have the number of moles of H3O plus ion in 1 dm³, I just need to multiply by the Avogadro constant. That will allow me to determine the number of H3O plus ion present in 1 dm³. So if I look at the expression here, it seems like I need to use Kc. I also have something called L. So I need to know what does L mean, right? So if you go to your data booklet, you will actually notice that L actually in this case represent the Avogadro constant. So that's why L appears in your options. And then you realize that in the option you also have 18. So what is 18? So you must remember that 18 here, right? 18 is actually simply the MR. 18 is simply the MR of water. Okay, so then how do we actually make use of all this information to calculate? So first of all, you see that the whole expression here has Kc, right? So definitely I need to make use of Kc. So I will use H3O plus OH minus over H2O squared. And in the option itself, right, I do not have H2O appearing in the expression. What I have is actually 0.99, I have 0.997 or 997 and 18 there. So I know for sure that I need to actually express my concentration of water in terms of that. So I can just simply use 0.997 divided by 18. So this will give me the number of moles in 1 cm³. So if I want the number of moles in 1 dm³, I just need to multiply by 1,000. So that tells me that this is equal to 99718 mole per dm³. Right? Cancel with this, then I can just manipulate this expression here in order to determine what is the concentration of H3O plus. So to do that, right, you need to actually kind of like understand the relationship between concentration of H3O plus and OH minus at equilibrium. So if you draw out the ice table, right, it is very obvious for you to know that at the start of the reaction, right, the concentration of these two will be 0. So when there is a change in the concentration, okay, so if let's say the change here is 2x minus 2x, right? So then if this is minus 2x, then the change is x and x proportionally, because it's 2 moles and this is 1 mole, 1 mole. Am I right? So therefore, what happened is at equilibrium, right, you expect the concentration of H3O plus and OH minus to be the same. Okay, it will be the same. So if it's actually the same, I can say that technically it just means that H3O plus squared is equals to Kc times H2O squared. So why is it so? Because concentration of H3 is equals to concentration of H3O plus is equals to concentration of OH minus at equilibrium. So with this, I can simply calculate H3O plus by taking the square root of Kc and H2O squared. Agree? So this means that this is actually Kc, and then this is simply H2O is simply just 99718 squared. Agree? So as a result of this, right, it means that it is 99718 square root Kc. Okay, so this would be the value in terms of mole per dm cube. Alright, so now if I want to know the number of H3O plus ion in 1 dm cube, I just need to use this value here to multiply by the Avogadro constant. Agree? So that's how I get 99718, and then I have L, which is the Avogadro constant, and Kc. So that is how you get the value, or rather the answer D.